Okay, welcome to another simple innovations video. And today's innovation, we are going to be retrofitting a blow molding machine that had an old PLC in it. The old PLC died. Some components could not be replaced because they're out of the market. And now we have to retrofit it with modern controls that are available in the market, that are repairable and that can be easily fixed, because the mechanical system is all in good condition. It's only the electronic control that is completely obsolete. So now here we have the famous S7 1200 PLC. We have the S7 1200 CSM 1277. It's the Ethernet switch for the S7 series. We have here with me SM1221 DC. That's an input module. So we're going to be having a few digital inputs expansion in this one. We have SM1231 TC. That's the thermocouple. The TC stands for thermocouple. So thermocouple temperature inputs are going to come in here for the machine. We have SM1222 relay. That's an output module that has relays as in the output. We have another one, a similar one, 1222 relay. We have which is similar to the previous one. It's going to also have some relay outputs, and this is the part of the control panel which already has HMI mounted, and so we are going to be going through the whole process of assembling the panel, doing all the wiring, doing all the connections, installing everything we need, including power and everything, all the way to programming the final code that to run the machine. All right, welcome to this journey with me. Thank you. Hello, welcome back. It's been quite some time since we spoke. So since then we've assembled the wiring. We've done all the wiring. This is for the thermocouples. These are for the digital inputs, the limit switches, all the inputs from the buttons, emergency stop, all of them are here. And then here we have the first bunch of outputs. Here is the second one, here is the third one, and here is the fourth one. Of course, we've removed the covers from the PLC, and now you can see the terminal connections. So next we are going to be doing the I/O testing, mapping out all the inputs, mapping them to this list that you have been using for reference, and so that we can tell which input corresponds to which PLC input. And then after that we will be ready to go and install the panel as we now start developing the program for the machine. All right, see you next time. So this is the machine I've been repairing. It's a blow molding machine. Here we have the mold. Here we have the blow pin. It goes in there and push it there into the pin. We have been fixing the heating stages. You can see the heating stages over there with fans and heaters. Coming on this side, we have the heaters in there. You may not see them, it's hot. They are getting ready to start tuning the machine. Yeah, here we have the hydraulic system and the valve block on that side. Here we have the hydraulic pistons for moving the flow hole, the mold over there, and the rails where the mold travels up and down. So here we have the mold in the in position. We have the cutter. It is a pneumatic cylinder, so it moves that way and back. We on this rear side, we have water supply for cooling the bolt, cooling various parts, the hydraulic oil. Here we have the hydraulic pump. As you can see, it's a 2-in-1. This is the one that drives the high flow, and this one is for the low flow. So you find that we are able to get remove things faster or slower without necessarily changing from one pump to the other. So this one is a 2-in-1, works perfectly. Here's the valve block, all the valves. Here we have the valves for the blowing up and down. We have the mold in, mold out. We have the main solenoid valve over there. We have all these other machines. So we've integrated all these valves into the new control system so that you can be able to control these machines from an UPS. Yeah, it's taken some time, but we are getting closer to commissioning. You can see the wiring for the old machine that we've integrated on some new wire. Over here is the motor for driving the screw, the extrusion screw. That's the hopper for the material, where we're going to be able to put in some plastic pellets, and the screw is going to push them through the heated sections over there, and then it will be extruded on the other side, and we are going to be able to make 5-liter jerry cans. So here is the pneumatics section, where we are driving the knife using pneumatics, as well as blowing air into the containers that we're going to be making. Here's the control panel. We have it here. This is the old one. We've put the new one on top of it. You can see it there. Here is some part of the old wiring that we are going to be doing some cable management later. On this front side, we have the PLC over there, the SF. So here is the HMI indicating all the variables, the status of the heaters, the blowers, the temperatures for the various sections. We did a lot of fine-tuning the machine, coordinating the process, making sure that all the inputs are read correctly, all the actuators are done correctly, and that the product produced is up to the standard. And it took us quite a long time, so we did this so many times, repetitions after repetitions after repetitions, tuning the code, tuning the mechanical system. The mechanical system had a lot of bugs because it had been lying idle for more than a year, but together with the operators and the technicians, we were able to figure out what parts of the systems needed to be repaired. We did that. We tuned again and again and again, reading IOs, changing the process, observing another similar machine operating nearby, and finally we were able to figure out all the parts, the cutting, the locking, the process, the temperatures. We were able to replicate all that. We were able to control them properly. We were able to calibrate them, calibrate the timing for all the functions, do all the interlocks for safety,
like the screw must only run when the temperature is high enough, and then if there is a problem, maybe if the mold does not open, or if the mold does not lock, or if the blow pin is not up, then make sure that the mold, the process stops, so that undesired operation is not seen. So it was quite an interesting big project because of the various number of IOs that we encountered, because there is quite a number of IOs, the variable frequency drive for driving the screw, the pneumatics for driving the knife, the hydraulics for driving the mold, all those. It's quite interesting. So we are looking forward to similar other projects when they arrive, so that we can revive these machines. Instead of scrapping them, we can give them a new lease of life. Here we see samples of the first production. These are jerry cans, 5-liter jerry cans that can then now be sold to guys doing shampoo, doing tomato juice, or any other product that can be packaged in 5-liter containers. So it was quite a long journey coming from a dead machine to finally a machine that's producing a product that can now be converted into cash. Sasa, I'll see you on the next one. Make sure to subscribe.
So in this video, I wasn't able
like
to show the nitty-gritties of programming the PLC. Maybe that will be shown in a future video. So stay tuned, stay creative, and let's keep innovating.